Hello. This will be a demonstration of proposition 33 from book 9 of Euclid's Elements, which says that if a number have its half odd, then it is even times odd only. In other words, if half of a number is an odd number, then you can only get that number by multiplying an even number by an odd number. You cannot get it by multiplying an odd number by an odd number, nor an even number by an even number. All we're given is the number a, and the only other information we're given about this number a is that its half is odd. So half of the number a is an odd number. And what we want to prove from this is that the number a is even times odd only. Now, it's just obvious that it is even times odd at all, because its half is odd. So it's going to be 2 multiplied by its odd half, making the number a, and 2 being an even number, its half being odd, so therefore it is an even times odd number. We also want to prove that it is only even times odd, so we have to prove that it is not even times even, nor is it odd times odd. For if it is even times even, then there will be some number which is even, there will be some even number which measures the number a according to another number which is even. So there will be some even number which measures a according to another even number. But if this is the case, then there will be some even number which measures half of the number a, which means that half of it can't be odd if an even number measures it. For if it were odd, then no even number would measure it. An even number never measures an odd number. So if an even number does measure any number, we know that that number is not odd. So because there is some even number which measures half of the number a, half of the number a is not odd. But this is contrary to our given, in which we said that half of the number a is odd. And so if the number a is even times even, then its half will be both odd and not odd at the same time, which is obviously absurd. And so we can say that the number a is not even times even. Now, Euclid doesn't go through the proof that it is not odd times odd, but it really only takes one step, so I imagine that's why he didn't include it. For if the number a is an odd times odd, then it will be an odd number, because we know from proposition 9.29 that an odd multiplied by an odd number can only get you another odd number. So if a is odd times odd, then it'll obviously be an odd number as well. But we know from our given that it is an even number based on the fact that its half is a number at all, that it does have a half. And so the number a would be both odd and not odd, which is impossible. And so a is neither odd times odd, which means that it is only even times odd, because we proved that at the beginning. And this is what we set out to prove, which means we're done with the proposition. Therefore, etc. QED. So an example of such a number would be 18, for example. 18 has its half odd, because half of 18 is 9, and 9 is obviously odd. Now, I do want to highlight the second step right here, which talks about if some even number measures the number a according to another even number, then there will be some even number which measures its half. How exactly that works is think of a number like 12, right? Now, sorry, 12 is a bad example. 12 is not what I'm going to go for. I'm going to go for 24. Because 12 is, whatever. So we're going to go with 24. 24 is an even times even number. It is 4 times 6. Now, because it is even times even, what that tells us that there is some even number which measures its half. This follows simply from the fact that, for example, you can break it up like this, right? And then, because you can divide its half like this, then there will be some even number which measures its half. And we see that this obviously holds for 24, because the even number 2, for example, measures its half, which is 12. But the problem you run into with a number like 18, is that if you do its half like this, you can't break these apart any further. And so if it is even times even, then we should be able to do this process where there's some number which measures its half again, some even number which measures its half again. But because both of its halves are odd, we know that there is no such number. And so that's how we get the absurdity, because if it is even times even, then some even number will measure its half. And if some even number measures its half, then its half obviously isn't odd, but we were given that it's odd, so that's how the proposition works. I hope that was a decent enough explanation of it, because that is the one weird step in this proposition. If it's still kind of confusing, of course, the comment section is always open. That's all I've got to say about this proposition, so I'll end the video here and move on to proposition 934.